Question 1. The line graph shows product days sales over 4 years. Which interval shows the greatest increase? Take a moment to compare each interval carefully. The correct answer is A, year 1 to year 2. Let's walk through this problem step by step and make sure we understand exactly what the SAT is asking. First, we need to calculate the change in each interval. From year 1 to year 2, sales increase from 100 to 120. Let's subtract. 120 minus 100 equals plus 20. Write that down. Next, look at year 2 to year 3. Sales go from 120 to 135. 135 minus 120 equals plus 15. That's our second interval. Finally, from year 3 to year 4, sales increase from 135 to 150. 150 minus 135 is also plus 15. Now let's compare all three changes together. 20, 15, and 15. The largest increase is clearly 20, and it occurs only once, between year 1 and year 2. That makes it the correct answer. Here's the trap that catches many students. When you first look at this graph, year 4 sits at the highest point, 150. So it feels like year 4 must be the answer. But remember, the question asks for the greatest increase, not the highest value. The ending height doesn't tell you how much the value changed. On the SAT, increase always means the difference between two consecutive points. It's about the slope, the rate of change, not the position. Always compare the steepness of each segment, not where the line ends up. Question 2. The bar chart shows monthly book sales by category. Fiction sold 80 units and comics sold 100 units. How much higher are comics sales compared to fiction, expressed as a percentage? The correct answer is B, 25%. Let's work through the percentage difference formula step by step. First, we need to understand what the question is asking. We want to know how much higher comic sales are compared to fiction. That means fiction is our baseline, our original value. Step 1. Find the difference between the two values. Comics sold 100 units and fiction sold 80 units. 100 minus 80 equals 20. So the absolute difference is 20 units. Step 2. Divide the difference by the original value. The original value is fiction, which is 80. So we calculate 20 divided by 80. 20 divided by 80 equals 0.25. Step 3. Convert the decimal to a percentage. Multiply 0.25 by 100. 0.25 times 100 equals 25. So the answer is 25%. Here's the most common mistake on this type of question. Many students divide 20 by 100 instead of 80. If you do that, you get 20%, which is answer choice A, but that's wrong because you must always divide by the original value, the baseline you're comparing against. In this case, that's fiction at 80 units. Another mistake is stopping at step 1 and just saying the answer is 20. But the question specifically asks for a percentage, not the raw difference. On the SAT, percentage increase or decrease questions always follow the same formula. Difference divided by original, times 100. Memorize this pattern and you'll never miss these questions. Question 3. The pie chart shows student club participation. Science club has 50 students, drama club has 40, sports club has 30, and art club has 30. What % of all students are in science club or drama club combined? The correct answer is B, 60%. Let's solve this step by step. First, find the total number of students. Science club has 50, drama club has 40, sports club has 30, and art club has 30. Add them together. 50 plus 40 plus 30 plus 30 equals 150 students total. Next, find the combined number in science and drama. 50 plus 40 equals 90 students. Now calculate the percentage. Take 90 and divide by the total, 150. 90 divided by 150 equals 0.6. Convert to percentage by multiplying by 100. 0.6 times 100 equals 60%. The most common mistake is adding 50 plus 40 to get 90, then choosing 90% from the answer choices. But that's wrong. The question asks for a percentage of the total, not the raw number. You must divide by the total first. Remember, when you see what percent, always divide the part by the whole, then multiply by 100. Question 4. The line graph shows the sales of product B over 4 years. In which year does product B have the greatest rate of increase in sales compared to the previous year? The correct answer is A, year 1 to year 2. Let's calculate each increase step by step. From year 1 to year 2, product B increases from 100 to 115. That's an increase of 15. From year 2 to year 3, it increases from 115 to 130. That's also an increase of 15. From year 3 to year 4, it increases from 130 to 140. That's an increase of 10. Now, we have two intervals with the same maximum increase of 15. Year 1 to year 2, and year 2 to year 3. However, the question specifically asks when product B first achieves the greatest increase. Since both intervals have the same increase of 15, we choose the first occurrence, which is year 1 to year 2. Here's an important SAT tip. When analyzing line graphs, always compute the actual difference between each pair of consecutive points. Don't rely on visual steepness alone, calculate the exact numbers. Also, pay close attention to keywords in the question. First, is a crucial word that tells you to identify the earliest occurrence of the maximum value. This tests your ability to read precisely and identify patterns in sequential data. Remember, on data analysis questions, precision in reading both the graph and the question wording is essential for success. Question 5. The line graph compares the quarterly revenue of Company A and Company B over 2 years. During the full period, which company grew faster overall? The correct answer is B, Company B. When a question asks, which grew faster overall, we need to compare the total change from start to finish, not just look at the final heights. Let's find the starting and ending values. Company A starts at 100 and ends at 180. That's an increase of 80. Company B starts at 80 and ends at 175. That's an increase of 95. But here's the key insight. When companies start at different levels, we should compare percentage growth to see which truly grew faster. Company A grew by 80 out of 100, which is 80% growth. Company B grew by 95 out of 80, which equals 118.7% growth. Company B grew much faster in percentage terms, even though Company A ends up higher in absolute revenue. We can also think about average growth per quarter. Company A gained 80 over 7 quarters, about 11.4 per quarter. Company B gained 95 over 7 quarters, about 13.6 per quarter. Company B's line has a steeper average slope. Here's the SAT tip. When companies start at different levels, comparing percentage growth helps identify which one truly grew faster overall. This approach accounts for the different starting points. Question 6. The bar chart shows the monthly sales of 3 book categories. Which category has the highest sales? The correct answer is C, comics. Let's read the exact values from the chart. Fiction has sales of 80 units. Nonfiction has sales of 60 units. Comics has sales of 100 units, which is the highest among the 3 categories. This is a straightforward comparison question, but it teaches an important lesson about data analysis. While comics clearly has the tallest bar, you should always verify by reading the actual numbers rather than just estimating visually. Here's a crucial SAT tip for bar chart questions. Always read the exact numbers above the bars or on the axis labels. Small visual differences can be misleading, especially when charts use different scales or when bars are close in height. The number labels are the most reliable way to compare categories accurately. Don't rely solely on visual height, your eyes can trick you, but the numbers don't lie. This habit of checking actual values instead of making visual estimates will serve you well on more complex data analysis questions where precision matters. Always look for the specific data points when making comparisons. Question 7. The bar chart shows the monthly sales of 3 book categories. What % higher are comics sales than fiction? The correct answer is C, 25%. Let's solve this step by step. First, identify the values. Comics has 100 units and fiction has 80 units. Next, find the difference. 100 minus 80 equals 20 units. Now, calculate the percentage increase. We divide the difference by the original value, which is fiction. 20 divided by 80 equals 0.25. Convert to percentage by multiplying by 100. 0.25 times 100 equals 25%. Therefore, comics sales are 25% higher than fiction. Here's the crucial SAT tip for percent difference questions. They always follow the same pattern. Difference divided by original times 100. The original is the value you're comparing from. In this case, we're comparing comics to fiction, so fiction is our base value. Choosing the wrong base value is one of the most common SAT mistakes. Some students might divide 20 by 100 instead of 80, getting 20%. But that's wrong because 100 is not the base, fiction is the reference point. Remember, A is X% higher than B, means divide by B, not A. Question 8. Look at the stacked bar chart showing quarterly sales for Category A and Category B. Which quarter has the highest Category B value? The correct answer is D, Q4. Let's examine each quarter's Category B values. In Q1, Category B is 50 units. In Q2, it rises to 75 units, an increase of 25. In Q3, it drops to 60 units, a decrease from Q2. In Q4, it jumps to 90 units, which is the highest value overall. Comparing all 4 quarters, 50, 75, 60, and 90. The maximum is 90 in Q4, making D the correct answer. Here's a crucial SAT tip for stacked bar charts. When reading stacked bar charts, treat each segment as its own data point. The key is to identify the individual segment values before comparing them, especially when colors or stacking patterns may distract your eye. Don't be misled by the total height of the bars. This question asks specifically about category B, not the combined total. Focus only on the green segments representing category B. Always extract the specific values you need from the chart or legend before making comparisons. Stacked charts can be visually complex, but breaking them down into individual components makes them much easier to analyze. This skill of isolating specific data segments will help you on more complex multi-category analysis questions. Question 9. Between which two consecutive quarters does the difference between the percent growth of category B and the percent growth of category A reach its maximum? The correct answer is A, Q1 to Q2. This is a complex question that requires us to calculate percent growth for both categories in each interval, then find the difference between those growth rates. Let's start with Q1 to Q2. Category A goes from 80 to 70. The percent growth is 70 minus 80, divided by 80, times 100. That's negative 10 divided by 80, which equals negative 12.5%. Category B goes from 50 to 75. The percent growth is 75 minus 50, divided by 50, times 100. That's 25 divided by 50, which equals positive 50%. Since we're looking for the difference between these growth rates, and they move in opposite directions, we calculate the absolute difference. Category B grows by positive 50% while Category A declines by negative 12.5%. The difference is 50% minus negative 12.5%, which equals 62.5%. Now let's check Q2 to Q3. Category A goes from 70 to 95. The growth is 95 minus 70, divided by 70, times 100. That's 25 divided by 70, which equals about 35.7%. Category B goes from 75 to 60. The growth is 60 minus 75, divided by 75, times 100. That's negative 15 divided by 75, which equals negative 20%. The absolute difference is 35.7% minus negative 20%, which equals about 55.7%. Finally, Q3 to Q4. Category A goes from 95 to 85. The growth is negative 10.5%. Category B goes from 60 to 90. The growth is positive 50%. The absolute difference is 50% minus negative 10.5%, which equals 60.5%. Comparing all differences. 62.5%, 55.7%, and 60.5%. The largest is 62.5% in Q1 to Q2. Here's the key SAT tip. When comparing percent changes, always compute growth rates individually first. We compare the absolute difference between the 2% changes, especially when growth rates move in opposite directions. Visual heights can be misleading because small or large starting values drastically impact the percent growth. Question 10. The pie chart shows the number of students who prefer each school subject. Which subject has the highest number of students? The correct answer is A, Math. Let's examine each category's values from the chart and legend. Math has 40 students, which is the highest value in the chart. Science has 30 students. English has 20 students. Art has 10 students. Comparing all four subjects, 40, 30, 20, and 10. The maximum is clearly 40 for math, making it the correct answer. This question demonstrates an important principle about pie charts. While math visually appears to take up the largest slice, you shouldn't rely solely on visual estimation. The legend provides exact numbers that confirm our conclusion. Here's a crucial SAT tip for pie chart questions. Always read the exact values or percentages in the labels or legend. Visual size and colors can be misleading, especially when slice sizes are similar or when different color schemes affect perception. The numbers give the most accurate comparison. Don't let your eyes trick you. Even if two slices look close in size, the actual values might differ significantly. This habit of checking precise data points rather than making visual estimates will serve you well on more complex pie chart questions where differences between categories are smaller. Question 10. If the school adds 10 more students to English and 5 fewer students choose science, which subject will have the second largest number of students? The correct answer is C, English. This question requires us to adjust the original values based on the given changes, then rank them to find the second highest. Let's start with the original values from the chart. Math has 40 students. Science has 25 students. English has 20 students. Art has 15 students. Now we apply the changes. English increases by 10 students, so 20 plus 10 equals 30 students. Science decreases by 5 students, so 25 minus 5 equals 20 students. Math and art remain unchanged at 40 and 15 respectively. Let's list the updated totals. Math has 40 students, English has 30 students, Science has 20 students, and art has 15 students. Now we rank them from highest to lowest. First place, Math with 40 students. Second place, English with 30 students. Third place, Science with 20 students. Fourth place, Art with 15 students. The subject with the second highest number of students is English with 30 students. Here's an important SAT tip. When values increase or decrease, always update all categories first before making comparisons. A small adjustment can shift rankings significantly, so rely on recalculated numbers, not the original chart. Don't try to estimate or make visual adjustments mentally. Write down the new values and compare them systematically. This methodical approach prevents errors and ensures accuracy on complex data manipulation questions. Question 12. The pie chart shows the number of students in 4 school clubs. What % of the students are in science club or drama club? The correct answer is C, 60%. Let's solve this step by step. First, identify the values for the two clubs we're combining. Science club has 50 students and drama club has 40 students. Next, add these two clubs together. 50 plus 40 equals 90 students combined. Now we need the total number of students to calculate the percentage. From the chart, Science club has 50, drama club has 40, sports club has 30, and art club has 30. The total is 50 plus 40 plus 30 plus 30, which equals 150 students. Finally, calculate the percentage. We divide the combined clubs by the total. 90 divided by 150 equals 0.60. Convert to percentage by multiplying by 100 to 0.60 times 100 equals 60%. Therefore, 60% of the students belong to either science club or drama club. Here's an important SAT tip for percent-based pie chart questions. Always compare part divided by whole, not the visual size of the slice. Charts with bright colors or large angles may feel bigger, but the number labels are the only reliable source on the SAT. Remember the formula. Part over whole times 100. This systematic approach works for any percentage question, whether combining categories or analyzing individual slices. Question 13. Which activity represents the largest percentage of the whole, and what is that percentage? The correct answer is A, sports 28%. Let's work through this systematically. First, we need to identify the values from the pie chart. Sports has 60 students, music has 50 students, reading has 45 students, and art has 45 students. Next, find the total number of students by adding all categories. 60 plus 50 plus 45 plus 45 equals 200 students total. Now we need to determine which activity has the largest number. Sports has 60 students, which is clearly the highest value among the 4 activities. Let's calculate sports percentage of the total. We divide 60 by 200, which equals 0.30. Converting to percentage. 0.30 times 100 equals 30%. Here's where it gets interesting. The exact percentage is 30%, but that's not listed among the choices. On the SAT, when the exact value is not available, you are expected to recognize that sports is about 30% and select the closest matching option that pairs with the correct category. Looking at the choices, A shows sports at 28%, which is the closest jar calculated 30% and matches the correct category, sports. Therefore, A is the correct answer. This illustrates an important SAT principle. On data analysis questions, choices may use rounded or approximate percentages. Always calculate the exact value first, then pick the option that is closest and matches the correct category. Don't rely on slice appearance, trust the numbers. Calculate precisely, then choose the best available match. This approach ensures accuracy even when dealing with approximations. Question 14. Using the histogram below, answer the following. Which class interval has the highest frequency? How many values fall in the 20 to 30 interval? Which interval has the fewest values? Let's answer each question systematically using the histogram. First question. Which class interval has the highest frequency? The answer is 20 to 30. Looking at the histogram, we can see that the 20 to 30 interval has the tallest bar, reaching up to 4 on the frequency axis. This means this interval contains the most values compared to all other intervals. Second question. How many values fall in the 20 to 30 interval? The answer is 4 values. We read this directly from the height of the bar for the 20 to 30 interval. The bar reaches exactly to the 4 mark on the frequency axis, indicating that 4 data points fall within this range. Third question. Which interval has the fewest values? The answer is 40 to 50. This interval has the shortest bar in the histogram, reaching only to the 2 mark on the frequency axis. Therefore, it contains the fewest values among all the intervals shown. Here's an important tip for reading histograms on the SAT. Always read the frequency from the height of each bar, not the width. The y-axis shows how many data points fall into each interval. Compare bar heights to determine which intervals have more or fewer values. Remember, in a histogram, taller bars mean higher frequency, and shorter bars mean lower frequency. This direct relationship makes histograms straightforward to interpret once you focus on the correct axis. Question 15. Use the histogram below to answer the following questions. Which score interval has the highest frequency density? What percentage of all students scored below 55? The teacher believes that more than half of the class scored 55 or higher. Does the histogram support this conclusion? Explain using data. Answer for question 1. The 50 to 55 interval has the highest frequency density. This question introduces an important concept, frequency density. We must compare frequency density, not just bar height, because the intervals have different widths. Frequency density equals frequency divided by interval width. Let's calculate each one. For the 40 to 50 interval, frequency is 3, width is 10, so density is 3 divided by 10, which equals 0.30. For the 50 to 55 interval, frequency is 2, width is 5, so density is 2 divided by 5, which equals 0.40. For the 55 to 70 interval, frequency is 3, width is 15, so density is 3 divided by 15, which equals 0.20. For the 70 to 80 interval, frequency is 2, width is 10, so density is 2 divided by 10, which equals 0.20. Comparing all densities, 0.30, 0.40, 0.20, and 0.20. The highest is 0.40 for the 50 to 55 interval. This is a crucial SAT concept. When histogram intervals have unequal widths, you cannot simply compare bar heights. You must calculate frequency density to make fair comparisons between intervals of different sizes. Answer for question 2. 50% of students scored below 55. To find this percentage, we add the frequencies of all intervals that lie below 55. Looking at the histogram, the intervals below 55 are 40 to 50 and 50 to 55. The 40 to 50 interval has 3 students. The 50 to 55 interval has 2 students. So the total below 55 is 3 plus 2, which equals 5 students. Next, we need the total number of students in the histogram. Adding all frequencies, 3 for 40 to 50, plus 2 for 50 to 55, plus 3 for 55 to 70, plus 2 for 70 to 80. That's 10 students total. Finally, calculate the percentage. 5 students scored below 55 out of 10 total students. 5 divided by 10 equals 0.50, which is 50%. Therefore, 50% of students scored below 55. This means exactly half the class scored below this threshold, which will be important for answering the next question about the teacher's belief. Answer for question 3. No, the histogram does not support the teacher's conclusion. The teacher believes that more than half of the class scored 55 or higher. Let's check this using the data. From the histogram, we need to count students in intervals that are above 55. There are 3 students in the 55 to 70 interval, and 2 students in the 70 to 80 interval. This gives us a total of 5 students scoring 55 or higher. Since the total number of students is 10, we have 5 out of 10 scoring 55 or higher. 5 divided by 10 equals exactly 50%. This means exactly half of the students scored 55 or higher, but not more than half. The teacher's belief was that more than half scored 55 or higher, which would require more than 50%. Therefore, the histogram does not support the teacher's conclusion. The data shows that exactly half the students scored 55 or higher, but the teacher believed it was more than half. The evidence contradicts the teacher's expectation. This question tests your ability to use precise data analysis to evaluate claims, distinguishing between half and more than half with mathematical precision. Question 16. Using the histogram, answer the following advanced questions. Which score interval contributes the largest share of the total distribution when measured by area? Estimate the median score range. Explain how you determined your answer from the histogram. A researcher claims, students scoring 55 to 70 represent more than half of all students. Does the histogram support this claim? Justify your answer. Answer for question 1. The 55 to 70 interval contributes the largest share when measured by area. This question asks about area, which means frequency times interval width. Area represents the actual proportion of the total distribution, not just frequency count. Let's calculate the area for each interval. Area equals frequency times width. For 40 to 50, frequency is 5, width is 10, so area is 5 times 10, which equals 50. For 50 to 55, frequency is 4, width is 5, so area is 4 times 5, which equals 20. For 55 to 70, frequency is 9, width is 15, so area is 9 times 15, which equals 135. For 70 to 80, frequency is 3, width is 10, so area is 3 times 10, which equals 30. Comparing all areas, 50, 20, 135, and 30. The largest is 135 for the 55 to 70 interval, which contributes the largest share by far. This demonstrates a crucial concept: the tallest bar doesn't always represent the largest share of the distribution. When intervals have different widths, you must consider area, not just height, to understand the true contribution of each interval to the overall distribution. Answer for question 2. The median score range is 55 to 70. To find the median, we need to locate the middle value when all scores are arranged in order. With 21 total students, the median is the 11th value. Let me count cumulative frequencies from left to right. The 40 to 50 interval has 5 students, so positions 1 through 5. The 50 to 55 interval has 4 students, so positions 6 through 9. Up to this point, we have 9 students total. The 55 to 70 interval has 9 students, so positions 10 through 18. Since we need the 11th position, it falls within the 55 to 70 interval. Therefore, the 11th student falls inside the 55 to 70 interval, which means the median lies in the 55 to 70 range. This estimate assumes the scores are roughly evenly distributed within the interval, which is a standard assumption when interpreting histograms. This process demonstrates how histograms provide ranges rather than exact values for measures like the median. We use cumulative frequency counting to determine which interval contains the middle value, then report that entire interval as our median range. Answer for question 3. No, the histogram does not support the researcher's claim. The researcher claims that students scoring 55 to 70 represent more than half of all students. Let's examine this using the data. First, count the students in the 55 to 70 interval. From the histogram, this interval contains 9 students. Next, find the total number of students. Adding all frequencies. 5 plus 4 plus 9 plus 3 equals 21 students total. Now calculate the proportion. 9 students out of 21 total gives us 9 divided by 21, which equals approximately 0.43 or 43%. For the researcher's claim to be true, we would need more than half, which means more than 50%. However, 43% is less than 50%. Therefore, the histogram does not support the researcher's claim. Although many students fall in the 55 to 70 range, they represent less than half of the total distribution, not more than half as the researcher believed. This question emphasizes the importance of using precise calculations to evaluate research claims rather than making visual estimates from graph appearances. Even when an interval appears prominent in a histogram, we must calculate the actual percentage to verify any claims about proportions. Question 17. The scatter plot shows the relationship between advertising spending and monthly sales for several stores. Which statement is best supported by the data? The correct answer is B. Stores that spend more on advertising tend to have higher sales. The scatter plot shows a clear positive association. As advertising spending increases along the x-axis, monthly sales generally increase along the y-axis. The upward trend of the data points supports this relationship. However, let's examine why the other choices are not supported by the data. Choice A says, increasing advertising spending causes sales to increase. This claims causation, but correlation does not imply causation. The scatter plot only shows association, not cause and effect. Choice C says, all stores with high advertising spending have high sales. The word, all, makes this too absolute. While there's a general trend, the data shows variation, not certainty. Some high-spending stores might not have the highest sales. Choice D claims, reducing advertising spending will decrease sales. This makes a definite prediction without evidence. The data doesn't show what happens when spending decreases. Choice B is correct because it uses the word, tend, which indicates a general pattern or tendency rather than claiming absolute causation or certainty. Here's the key reminder. Correlation does not imply causation. Scatterplots can show associations and trends, but they cannot prove that one variable causes changes in another. Question 18. A marketing manager looks at the bar graph showing average monthly sales for two groups of stores. Because Group B has higher average sales, the manager claims that stores with higher advertising spending generally perform better and that the company should continue to increase advertising spending. Which statement best evaluates the manager's reasoning? A. The manager's conclusion is correct, because higher average sales prove that all stores in Group B perform better. B. The manager's conclusion may be reasonable, but the average alone does not show that all stores in Group B have higher sales. C. The manager's conclusion is incorrect, because higher advertising spending causes lower sales for most stores. D. The manager's conclusion is incorrect, because Group A has lower average sales. The correct answer is B. The manager's conclusion may be reasonable, but the average alone does not show that all stores in Group B have higher sales. Let's analyze why this is correct. Group B does have a higher average monthly sales value, approximately $60,000 compared to Group A's $50,000. However, an average alone does not tell us how individual stores performed within each group. Looking at the scatter plot on the right, we can see the individual store performance. While Group B's average is higher, there's significant variation within both groups. Some stores in Group A actually outperform some stores in Group B. A small number of very high-performing stores in Group B could raise that group's average, making it appear that all Group B stores perform better when that's not necessarily true. Now let's examine why the other choices are not supported. Choice A says the manager's conclusion is correct because higher average sales prove that all stores in Group B perform better. This is wrong because averages don't prove anything about individual performance. Choice C claims higher advertising spending causes lower sales, but there's no evidence for this in the data. Choice D simply restates the comparison without evaluating the reasoning, which doesn't answer what the question asks. The key reminder. Averages can be misleading when a single outlier or a few extreme values affect the distribution. Always consider individual data points, not just summary statistics. Question 19. A manager wants to determine the overall average daily sales for stores A, B, and C combined. Based on the information shown, which method is best supported by the data? A. Add the 3 average daily sales values and divide by 3. B. Add the 3 average daily sales values and divide by the total number of days. C. Calculate a weighted average using the number of days for each store. D. Add the highest and lowest average daily sales values and divide by 2. The correct answer is C. Calculate a weighted average using the number of days for each store. The goal is to find the overall average daily sales across all 3 stores combined. However, each store contributes a different number of days to the data collection, so their averages should not carry the same weight in the final calculation. Store A has an average of $300 over 2 days. Store B has an average of $150 over 4 days. Store C has an average of $100 over 10 days. That means their total sales are $600, $600, and $1,000 respectively, across 16 days in total. An overall average must be based on these totals, not on a simple average of averages. Using the number of days ensures that each store's data contributes proportionally to the overall average. Store C, with 10 days of data, should have more influence on the final average than Store A, which only has 2 days of data. Now let's examine why the other choices are incorrect. Choice A simply averages the 3 values, treating each store as if it contributed the same amount of data, which is not supported by the information shown. This would give equal weight to all stores regardless of how much data each contributed. Choice B divides the averages by the total number of days, which mixes incompatible quantities and does not correctly reflect how the data were collected. Choice D uses only the highest and lowest averages, which ignores much of the data and has no support in the information provided. The weighted average method properly accounts for the different sample sizes, ensuring that stores with more data points have greater influence on the overall result, which is the most statistically sound approach. Question 20. A survey recorded the average nightly sleep time of adults over several years. Based on the data shown, which statement is best supported? A. Average nightly sleep time will continue to increase in future years. B. The increase in sleep time proves that adults are making healthier lifestyle choices. C. All adults will get more sleep if this trend continues. D. Average nightly sleep time has generally increased during the years shown. The correct answer is D. Average nightly sleep time has generally increased during the years shown. The graph shows how average nightly sleep time changed from 2019 to 2023. Over this period, sleep time increased from approximately 6.2 hours to 6.8 hours. This represents a clear upward trend during the years displayed. Choice D is correct because it stays strictly within what the data directly shows, without making assumptions about the future, causes, or individual outcomes. Now let's examine why the other choices are not supported by the data. Choice A makes a prediction about future years, which is not supported by data from past years alone. Past trends don't guarantee future outcomes, and many factors could influence sleep patterns going forward. Choice B claims a cause and effect relationship and introduces a value judgment about lifestyle choices. The data shows correlation but doesn't prove causation, and we cannot determine from sleep time alone whether people are making healthier choices. Choice C makes a statement about all adults, but the graph shows only an average, not individual outcomes. Averages can increase even if some individuals sleep less, so we cannot conclude anything about what will happen to every adult. This question demonstrates the importance of distinguishing between what data actually shows versus what we might infer or assume. Good data analysis requires staying within the bounds of what can be directly supported by the evidence presented.